Okay. So back to normal, back in the room. Yeah, so the furnace guy came out on Thursday, looked at our furnace, came up with a pretty good sized repair bill for it. So we then had them send out a guy to give us an estimate on a new furnace. So he came out, gave us an estimate, and we were going to do that. But then all of a sudden, in the middle of the night on early Friday morning, the furnace decides to kick back on. So it is now working, which now buys us some time to find and get some more estimates on a new furnace other than the first guy who could answer our call. So it is working at the moment, but it is making a lot of noise. So who knows how long it'll live for. All right. That was my weekend. The lowest our house got down to is like 54 degrees. Chilly. All right. Any questions? All right. Everybody knows everything. I can go home. All right. Oh, let's see. The question about the homework. What was it? 1.5 homework. I think it's question number 4, you said? 1.7, number 4. They give you a bunch of points. They want you to find a regression coefficient. You can do that on Desmos. Just type in the table. Desmos will do it. Okay. And for those of you who actually have a graphing calculator, you can actually have your graphing calculator do it for you. Okay. It can do that. You just have to know how to make it do that. Okay. All right. All right. Oh, let's see. Then last week there was a group quiz. Everybody was able to get to it, open it, get a copy of it. I think some people turned it in. Huh? Oh, you're going to turn it in that way? That's fine. Yep. Anybody else? Anybody else is good? You weren't. All right. So I actually did make some paper copies. Just in case. But we did do it online. Right. All right. Anybody else? Right. All right. All right. All right. And she wants one to feeling left out. Right. All right. All right. Right. So we are on to chapter 2. So, systems of equations. So, given something like that, right? So, we want to be able to find out in terms of the x and the y value. Okay? So we want to find out where do these two lines intersect. There we go. They're both equations of a straight line. You can tell that because, again, there is no exponents on anything, right? And so we saw from last week, we had stuff like this we did. So we did ones like that last week, where we were able to find out where those two lines intersect, right? So basically last week we said, okay, you would then take my two equations and you set them equal to each other. Right? So we take a few moments and figure that out. Find the x and the y for this one here. This is what we did last week. Right? So minus 5x plus 10 equals 3x plus 4. You get a fraction. That's okay. Nothing wrong with fractions. Right? So you should be able to determine both the x and the y given that set. All right, so I'm going to find x and y for this one. All right. Right. And with the value of x. And we want the value of y for this one. Let's see. Right. So anybody got the answer? What's x here? 3/4? Everybody's got 3/4? Everybody's saying 3/4? All right. So let's see. So we would end up bringing the 5x over. Take the 4 over. So 6 equals 8x. And then divide. And we get 3/4. All right. What is the corresponding y value? I get the x and the y. X and Y. And the answer is silence. The Y value, what's the Y value? 25 over 4. You got 25 over 4? 25 over 4. Okay, you got a few of them. All right. So we got Y equals 3 times 3/4. So this is 9/4. The 4 I can rewrite as 16 over 4. And you get 25 over 4. All right. All right. All right. So that's what we did last week. All right. So now let's look at this new problem I have here. All right. So if I want to do this by what we did last week, what do I need to do first? No, I can't do that. Okay, what do I have here? Where was my starting point last week? My starting point was here, right? Where we had Y equals, okay? So that would mean now for both of these, for these two, I want you to take these equations and solve each of those for Y. Right? So take the top equation, solve it for Y. Take the bottom equation and solve it for Y. Right? So we should be able to do that. Take the equation, solve for Y. Right? So take each equation and solve for Y. Okay? And how are all my online folks? Oh yeah, you should be able to take each one of those and solve for Y. Yeah, that would be, yeah, mx plus b form, yeah. Yeah. Will sort of look like what we had the other one you just did, okay? Okay. All right. So I'm going to solve each one for Y, okay? So really in each case, the first step is going to be to bring over the X term, right? So we subtract the 20X. So 30Y equals a minus 20X plus, right? And then the opposite of multiplying is to divide. So we divide everything by 30. And so y, this will be a minus 2/3 x. And then 30 goes into that. $130, right? 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 And then we would take the other equation and do the same thing. So here we take the 15x. So 30y minus 15x, 3,300. And again, divide by the 30. And y will be 15, this will be a minus 1/2 x. And then 3,300 divided by 30 is 110, right? All right. Okay. So we took both equations and we solved for y. All right. All right. Now that they're both solved for y, now determine the x and the y value, like we just did previously. They're both solved for y. So now you could actually set them equal to each other. Okay. Of course, now you got fractions, but there's nothing wrong with fractions here. Okay. After all, fractions are numbers too. Actually, get rid of this for a moment. And rewrite that over here. Right. So you got set those equal to each other and solve for x. And of course, once you get the x value, you want to find the corresponding y value, which you can use by either one of those two there. So the x and the y. Okay. And they should both come out to be nice whole number answers. When all said and done with this. All right. X and Y, and both numbers will be nice whole number answers. So if you're not getting a whole number answer, then you need to try again. Yeah, X is 120. Okay. X number is good. Nope. Because after all, what is minus 1/2 times that? Minus 60, right? Then plus that, right? Okay. because yeah, you drop the negative. Okay. New number, right? Okay. New and improved. Got numbers? Yes. And those numbers are?
X would be 1.
Correct. All right. Numbers, numbers. 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 Fraction part. Fractions. There's nothing wrong with fractions. Numbers? Correct. All right. Okay. All right. Okay. All right. Says you get 2 whole number answers for this. Right. Right. Yes, you do have to deal with fractions in this right now, but that's, there's nothing wrong with fractions. Okay. All right. See, so the X number is, what was that? X number was 120. You got 120, you got it right. And the Y number is 50. Okay. All right. So how do you actually get it? All right. So you got this thing. Yeah, you have fraction, but it's okay. Nothing wrong with fraction. Okay. So depending on how you want to deal with your fraction, but I got a 3 and a 2. What's the common denominator? 6. All right. So let's multiply the entire thing by 6. 3 goes in the 6 how many times? 2 times the negative 2 is? 2 times the negative 2 is? Okay. Right? 2 times negative 2 is a minus 4. What is 6 times 130? 780. Okay. What is 6 times a minus 1/2? So minus 3, right? What is 6 times 110? 660. Okay. All right. Right. All right. So I multiply the entire thing by the common denominator. And we now get rid of all those things that you all love, which is fractions. Okay. Right. So now we can solve this. Okay. And so if I bring the 4x over, take the 660 over, you end up that x equals 120. Okay? Okay? So if you don't like fraction, you get rid of fractions by multiplying everything by the common denominator. Okay? You want to do that? Okay. You could have done the problem just dealing with the fractions. After all, your calculator will deal with them in terms of that, as far as that's concerned. But now that we know that x is 120, we can find the y value, because we had y was equal to a minus 1/2 times 120 minus 1/2 times 120 is a minus 60, plus the 110 takes us to 50. And we get our numbers. Right? All right. Now, that was a lot of work in terms of solving this problem. Because after all, we had the first take what I gave you. You need to solve each one of those for y. Then set those two equal to each other. Find the x number. And then find the corresponding y number. Okay. So that was quite a few steps to solve it. Right. So everybody's good with this going away? Going. All right. So let's try it again. Right. So let's put these back up on the board. All right. All right. So write this one better. Same problem. We know what the answers are. Right. We just did it. So there are other ways of solving this, right? So first way is substitution. Right? And we'll do that one. So what you would do is you take either one of the two you have, okay? And you solve for either x or y. And we already did that. After all, over here, we took the top one and we solved it for y. Right? We also did it for the bottom one, we solved for y. Okay, we actually did both. Right? But that would be the first step. Take your equations and solve for either x or y. You can actually do either one, doesn't matter. Okay. Now we get to why this is substitution. You now take whatever you got. So we're going to take what we got here and we're going to substitute it into the other equation, right? So we use this equation to get this, which means when we substitute into the other equation, okay? So we're going to take what we have here and we're going to plug it in there for the y value, right? So now this will be 15x plus 30 times the minus 2/3 x plus right? Right? So I substituted. I took the y out and we plugged in this into its spot. Right? Right? That's good. Right? We do a substitute. Okay? So now I have this equation, which is only going to be in terms of x. So this will be 15x. 30 times a minus 2/3. Minus 20, right? So this is going to be a minus 20x. 30 times 130. $3,900, yep. So now we have that, right? 15x minus 20x minus 5x, right? Right? Okay. So everybody should be able to finish that and solve that for x. Okay. So you got a minus 5x plus 3,900 equals 3,300. Everybody should be able to finish that. Get the x value. And you know what the x value should be already. So if you got the same number as we got earlier, you did it correctly. Oh, that's okay. All right. So I bring the 3,900 over. And you have a minus 5x equals a minus 600. You divide by the negative 5, and you get exactly the same answer. Right? And we end up at 120. And then, of course, we could plug that in and get the y value and get the same number back again. Okay. All right. So that's one way of doing it. Substitution, right? A little less work than the other way. Okay. Cut down the work a little bit. Right. So Bailey, you take either one, solve for x or y, your choice. Bailey, whichever one will make you so you have nicer numbers to play with, basically. Right. Take that, plug it in, and then solve. Once you get the one variable, then find the other variable. All right. Right. Have a question about that? All right. I don't like this way, but now let's go the other way. All right. This can all go. All right. Other way. Right. Of doing this. All right. All right. All right. Now let's see. We said we could take both equations, solve it for y, set those equal each other, then get the answers. Or then we just did substitution. But then we get to the other way. And that way is elimination. Right? Everybody online can see my board okay, right? All right. So now in elimination, we really want to get rid of a variable. This whole process here. We want to eliminate, okay? You can pick whatever variable you want to get rid of. Right? Whether we want to get rid of the x or we want to get rid of the y, okay? Our choice, okay? In this case, which one's going to be easier to get rid of, the x or the y? Because I want to know the answer. Person, right? All right, the y is going to be easier, right? Because after all, this is a 30y, this is a 30y. Okay, that's easy. They both have a 30. The only problem here is one positive, one they're both positive, but we can take care of that in a moment, right? So what we're going to do is we're going to leave the first one exactly the way it was. 20x plus 30y equals 3,900, okay? And now the bottom one, I want to make it a minus 30y. And so I'm going to take the bottom one and multiply everything by -1. So this will be a minus 15x minus 30y equals a minus, right? Add those two together. What do we get? So if I add those two together, what do we have? So we end up, after all, 20x minus this is 5x. The y's go away. And this will now be 600. Okay. And of course, now we just divide by 5. And we get x will be 120. Okay. And now in this method, the next thing you would do is you would take your answer we got there and you would plug it in to either one. Okay. So let's do that. So this will be 20 times 120. Right. Well, let's see, 20 times 120. Twenty times 120 is. So this would be 2,400. Right. Right. And we want to solve for y. So now we take the 2,400 over. And we now have 30y equals 1,500. Right. And then we divide by the 30. And we end up with our answer, which we've seen before. And we get that. Right? So we did the same problem by 3 different ways. Right? And then you are so happy that you did this problem and you got it done. You go to MATHP and they want the answer in terms of a point. And so you type your answer in the MATHP and you type it like that. And what does MATHP do? It says you're wrong, right? Okay. You got the numbers right, okay? But it is an XY point, right? Which means, yes, the first number is the X value, okay? And the second number is the Y value, okay? So you do need to make sure you type them in the right spots, right? 120 and 50. So you want it like that, okay? Now I know you got the numbers right, but you got them in the right position when you type it in, okay? All right? Right? All right. Right? Where do you go with that? Right? All right. So there are 3 ways of doing this same problem. Okay, maybe you can pick whatever one you like. Okay, as to your choice as to how you want to do it. After all, whatever method you pick, you should end up at the same answer. Okay, so even on MATHP on the homework, if it says solve it by method A, You can solve it by whichever way you like. After all, I'm not going to be standing over you, watching you, making sure you did it by method A. Okay, all right. All right. So whichever method you like for solving. All right. So this one. Right? Right? So I'm going to do this. Let's do this by elimination. Right? That's the one I like better, personally. Right? So the first thing you got to do is decide which one you want to get rid of, the X or the Y. Okay? So in this case, one like this, if I see one where I already have where one is a positive, one is a negative, then I'm going to decide to get rid of that variable first, right? So I'm going to get rid of the X's first, all right? So now I need a number that 2 and 3 both go into 6. So we're going to take the top equation, multiply everything by 3, and we're going to take the bottom equation and multiply everything by 2. Okay? Okay. So I multiply here everything by 3, and we end up with a 6x, a 9y, and let's be 69. And then here we get a minus 6x, minus 8y, and a minus 18. Okay. Okay. All right. So at that point, everybody to finish that, give me the values for X and Y. Okay. Should come out to be 2 nice whole number answers, okay, for this one. Well, again, you get 2 nice whole number answers for this, right? Right. Got numbers? There's one number. Yeah, but gotta get the other number. Okay. So yeah, I want to get the X and the Y. Okay. And yeah, they both will be nice. Mm-hmm. So what are we doing first? Right. And we get the X number and the Y number. And both come out to be nice whole number answers. Right? Yep, that'd be right. Nice whole number answers, right? Which makes everybody in the class happy. Whole number answers. Fractions. Got numbers? And the numbers are? Right. Numbers. Numbers. No. Right. What? I mean, which one's the X? Right. 69 minus 18, right? Well, no. Now, what's minus 9y minus 8y? Okay. All right. All right. All right. So we got this. Okay. Next step here is to add these two together. So a minus 9y and a minus 8y takes you to a minus, all right? And then 69 minus 18 is 51, okay? Now we just have that. And now you can solve that for y, because that's now just a matter of dividing. So we divide by the minus 17. And y will be -3, okay? All right. And then once you have the y value, you need to go back to either one of the original two. So if I take the top equation, which was 2x minus 3y equals, and now we're going to plug in the -3 for y. So this will be 2x minus 3 times a minus 3. So 2x plus 9 equals 23. Take the 9 over. So 2x equals 14. Divide by the 2. And we get x equals 7. So we have the point 7, -3 for the answer. Right? Any question on that one? On the process? How it all works? Oh, over here? You could. Yeah. Yeah. Yep. All right. Ready to go with that one? All right. Let's try a new one. All right. So solve this one. And again, you get two nice whole number answers. So everybody gets to start, do that one from scratch. So I want to solve that one. Nice. And again, you should get two nice whole number answers for this one. So two nice whole number answers. I think. Hold on, let me think about that. I mean, before I, let's see, is it two number answers? I'm not sure. Maybe not. Different problem. Either way, whole number answers or not, you should be able to do it. And I don't think you get whole number answers. I'm mistaken. Yeah. Right. Yeah. So this time, yeah, you are going to probably end up with a fraction. Wrong. Different problem. Right. But it's okay. There's nothing wrong with fractions. After all, fractions are numbers too. If it's a fraction like 1/4, 0.25 is fine. If it's a fraction like 5/7, which that does not become a nice decimal number, it's not a nice decimal number. Only if it comes out to be a nice terminating decimal. Otherwise, it should be fractions. Okay. Because fractions are the exact answer. Anything else is however many digits you decide to write down. Well, it depends on the question. Like on the homework, you could say, like if it says round it to X number, then that's fine.
Just say four columns.
Yeah. But unless the problem says round to X number of digits, then you should always give the exact answer. Right? But again, this one probably does come out to be fractions, but that's okay. There's nothing wrong with fractions because everybody in this class enjoys fractions, right? No, isn't that true? What's wrong with fractions? Come on now. Nothing wrong with fractions. All right. Yep. Another one. All right. Where's my mouse? Buried. All right. All right, let's see. We have 1, 2, 3, 4, 5, 6 people online today. I think 7, 8, 9, 10, 12, 13 in the room. All right, not bad. Let's see. So, I get fraction, but that's okay. Nothing wrong with fractions. Fine. You get nice fractions here for this one, but that's okay. Turns out to be in terms of 39ths, but that's all right. 39ths. Huh? You got it right. And the y is correct. All right.
When you multiply negative, it's negative 12.
You get, yes, both should be positive. Okay. Again, it does come out to be fractions, but again, you can, nothing wrong with fractions. Okay. That's the calculator can deal with fractions. And then again, your calculator can take your decimal number and convert it into fractions. Okay. So, because again, this one, you're not going to get a nice decimal form for this. Okay. All right. Right. So we have this thing. And again, the first thing we want to do is get rid of the X or the Y. And so what do we want to get rid of first? The Y. Okay. So if I get rid of the Y, I got a 5 and a 6. So that means they both go into 30. So that means I'm going to take the top equation, multiply everything by 6, take the bottom equation, and multiply everything by 5. Okay. All right. So we multiply everything by 6. So let's see, this will be 24x. This is a 30y, and that'll be 60. This will be a 15x and a 30y. And this will be 40. Add those two together. And so the y's go away. And we get a 39x equals 100. And then we divide. And we get the first of our lovely fractions. And so x is going to be 100 over 39. And that is not going to be a nice decimal number. So we leave it like that. Okay. All right. Okay. Okay. Yeah. Either way. Yep. You can do either one first. Either way, you should get the same point. So now that we know the x is, you now have to take that answer and plug it into either one of the originals, right? And so let's do, we got 3x plus 6y equals 8. This is 100 over right? So 3 times that will give us what? Three times 100 over 39 will give you 100 over 13, right? If you reduce it, which is what your fraction will, what your calculator will do. Your fraction will automatically take care of that, right? So this will be 100 over 13 plus 6y equals 8, right? And then, of course, now we want to subtract. So minus 100 over 13 minus 100 over 13. But of course, the 8, we need to rewrite in terms of 13ths. And what does that give you? What? 104? 104 over 13, right? Got to rewrite the 8 in terms of 13s, right? Right? Okay. So now we have 6y equals 4 over 13. Right? And let me just bring this up here so it'll be higher. Next step is to divide by 6. And you end up at y will be 2 over 39 when it's all said and done. Right? Nice fractions. Okay. See, some of you got that, even though it's fractions, there's nothing wrong with fractions, right? Again, you could either give her the x's first or the y first, it doesn't matter. Whichever way, you should end up with the same final answer when it's all said and done, okay? All right. And then again, you would give your answer in terms of a point. And again, given this one, fractions are the way to write the answer, okay? You don't get nice terminating decimal numbers for this, okay? So unless the question said round your answers to X number of decimal places, you're going to use fractions. Which fractions are the exact answer. Right? Any question on that one? Yes. Yeah. Yeah. Like that first one we did. I left the one alone and I multiplied the other one by -1. Okay. Yeah. So you can switch the signs by multiplying by a negative. Okay. All right. All right. Let's see. This can all go. Going. It's going and it's gone. All right. All right. Well, another way they can ask you the question is they'll give you a set of equations, and then the question now is 6 - 2 the answer. Right? So they give you the equations, they give you the point, and they want to know, is that the correct answer to this system of equation problem? Right? Right? Which means you got a 50-50 shot at getting it right, because this is actually a yes or no question. Okay? Because either it is or it isn't. So you can answer this question by one of two ways, right? Yes? Got an answer? Right. Okay. Yeah. Yeah. So you can do this two ways, right? One way is plug it in. See if it works, okay? So you say, okay, well, we plug it in. So this is going to be 4 times 6 minus 3 times a minus 2. This is going to be 24 plus 6. Well, that works, okay? But you can't stop there. Because in order to truly be the solution, it also has to work in the other one. So is 2 times 6 plus 7 times a minus 2. So this is going to be 12 minus 14. And does that equal 20? No, right? This is not true. So no, 6 negative 2 is not the solution, okay? All right. So if they give you something like that, that is one way of finding the answer. Really just take it. It has to work in both in order to truly be the solution to this system of equations, okay? Well, now that we know that 6 negative 2 is not the answer, we'll leave this for the next problem. And that is, what is the answer? And again, it might come out to be fractions, but that's okay. Everybody dealt with 39ths on the last problem. So everybody should be able to deal with this one, right? So what is the solution to this system of equation problem? Because this doesn't work. So the question that is, what is the x and the y, right? And again, probably come out to be fractions, but that's all right. We should be able to come up with the answers, even though it's fractions. And it comes out to even more lovelier fractions. Right? But that's all right. Everybody here is a fraction expert now. All right. Hmm.
I simplified.
So yeah, where are you going? Yeah. But this is the minus. That should be a minus 40.
Well, should be a minus.
If you're getting rid of the x's first,
Oh,
right?
yeah.
Okay,
True.
true. Okay. Uh-huh. Okay. Again, you get lovely fractions for this one. Okay. Okay. Let's see. Not quite. Okay. A few more moments. Yeah, numbers?
So.
No. Oh. Uh-oh. Oh, on your calculator? Ooh,
Yeah.
make this brighter.
Oh, yeah.
You can't even see how to make it brighter. Okay.
There we go.
Oh, let's see. Does it? Not that I can tell offhand. Is this your iPhone calculator, right?
Yeah. I have one like coming on the way. I ordered
Okay.
a real
A
calculator.
real calculator. All right. Okay. Yeah, because I think decimal wise, I think you're okay. But of course, that's not a nice decimal number.
Yeah.
And nothing handy there that can see in all the keys they're giving you. Yeah. Okay. Yeah. Okay. Yeah, numbers. Correct. Hey, Marcy, you like fractions. Well, right. Well, that's what the calculator for, right? No, we got.
Same?
No,
No, you sure?
no, I'm sure.
Which one?
Which one? Both.
Both.
No, let's see. Let's see. No, let's see. The other one. No, one might be right. Let me see. Let me check.
What? One's correct.
Huh? One is correct. The Y is correct.
The Y is correct. What's wrong with it? Probably can't be kidding.
All right. All right. Let's see. How are we doing here? Numbers? Oh, yeah. No. Let's see. You're getting rid of the what first? Right. Problem here is I have to make one positive, one negative. Okay. So right now these are both positive. So if I add these up, the x's are still there. You didn't get rid of the x's. Okay. So you would have to make one plus, one minus. Right. Right. Her iPhone calculator. Oh, you got. Oh, yeah, different. Oh, yeah. Oh, you put a different calculator on there. Okay. So now what do you get? What do you get for your answer?
945.
I mean 945. What? No. How'd you get 55? You weren't at 55 before. You weren't at 55 before.
It gave me that, I think.
No, you were not at 55.
Okay, 7 times.
Yeah, okay, you were at, yeah. Okay, all right. Calculators, all right. It should be what? Not by itself. I mean, it's not just 135. No. Your X number is not just 135. Okay, all right. Okay. Okay, all right, let's go through this one, then we can take a little break. All right. So you get this one again. We want to get rid of either the X or the Y, okay? And again, for me, I would start with the Y's first because I already have a plus minus situation going on here, right? So I would take the top one, multiply everything by 7, and take the bottom one and multiply everything by 3. Right? That way the Y's will go away. So let's see. So this is going to be a 28X minus 21Y equals 210. Right? And then take the bottom equation, multiply everything by the 3. And so this is going to be 6X, 21Y, 60. Okay? Okay. Add those two together. So this will be 34X. The Y's go away. And over here you have 270. Okay. Divide by the 34. And X, well, that fraction can be reduced because after all, 2 goes to both top and bottom. And you end up at 135 over 17. Okay. Okay. Right. So Katie, I think on your calculator, you originally had something like 7 point something. Not that 55. You popped in later. We're not sure where that came from. Okay. All right. So now that you know that X is that number, you now need to find the corresponding Y number. And so if we go 2 times 135 over 17, well, let's see, 2 times that is going to be 270 over 17. Okay. Subtract that. Okay. And of course, in order to do that subtraction, we need to have our common denominator. And so 20, I can rewrite as 340. Okay. So 340 17ths minus 270 17ths gives you 70 over 17. And then divide by the 7. And we end up Y is going to be 10 over 17. Yes. Here. In order to do this, I want a common denominator. Well, again, remember this, any whole number is over 1, right? So what's the number that 1 and 17 both go into, right? Okay. Right. All right. And with that, let's take 10. Resume recording. Okay. Let's see. So the ones we've done, we've been able to find an X and a Y value. Okay. So we're able to find an answer. And in terms of the book we're using, they call this type an independent system. All right. Basically, what we have happening in the questions we've been doing is we've been having something where we have one line going like this. We had another line going like that, and we've been getting an answer. So we get one answer, okay? Okay. And again, in terms of the book, it's calling that an independent system. We get one answer where they cross, all right? Just in terms of terminology. Okay. All right. Yeah. Right. Right. All right. So solve that one. Okay. 4x minus 5y equals 12, 8x minus 10y equals 6. Solve that. Right? That one. 4x minus 5y. Yes. Right. Solve this one. All right. And remember, if you need math help, I have office hours after class, also on Zoom at the same time. Okay. And of course, we also have in the room our tutor who's here, and it also has his own office hours. And also there is the Math Resource Center up in the library, top floor, where you can stop in and find somebody to give you help. Okay. 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 Again, we want to solve this one I wrote there. Math. Why? What's the matter? Why are you already questioning if you did it wrong or right? What are we multiplying by? What are you getting rid of first? Then one has to be positive, one has to be negative. Okay, you multiply both by a positive. Okay. You need to have one of each. If you're going to get rid of, okay. Right. So, right. Problem? Problem? Yeah. Okay. So is there a problem?
So I can do that?
You can do the math.
It's gonna be no solution.
All right.
So this one's no solution.
You can do the math, but you get something that makes no sense, right? Okay. All right. So yeah. So again, you want to get rid of the X or the Y's. All right. So if I decide I want to get rid of the X's, for example, then I'm going to leave this one alone, multiply this by a -2. Right. So we get a minus 8x plus 10y equals a minus 24. And this is an 8x minus 10y. Add those together, and what happens? The x's go, the y's go, and you're left with 0 equals -18. Is that a true statement? No, right? This is not true. So what's happening here? What is going on? Why is there no solution? That is true, but why is there no solution? What's going on with my lines? There's a reason why we're getting no solution. It has to do with my lines. What? They're parallel, right? If you end up getting a statement like this, okay, it's because my lines are parallel. Right? These two lines would be parallel to each other, okay? And that's why we're ending up with that 0 equals -18. We end up with something that obviously is not true, okay? All right. So in terms of the book, it calls this an inconsistent system. Okay. All right. And basically here, what's happening is that the lines are parallel. Okay. So they never intersect. So there are no answers in this case. All right. Right. Again, if you get something like that, where you get 0 equals some number, whatever that number might be, okay, then we actually are looking at having parallel lines, and therefore there are no solutions, okay, to it, okay? Right. Right. Everybody's able to get 0 equals -18 and figure out that that's not true. Okay. All right. Yeah. All right. Okay. How about Right? Everybody take a moment and figure out that one. Right? What's going on with this set? All right. What happens with this one? Right? This time you do a little math and you end up with something that says, okay, they end up with what? And what about the other side? Both zeros, right? So this time you should be ending up with a statement that says 0 equals 0. Is that a true statement? Yes. Okay. All right. We already. Okay. So let's see. If I want to get rid of, so let's get rid of the x's. So I multiply the top by a -3. Okay. And so we have a minus 12x plus 15y minus 36. And a 12x minus 15y equals 36. And we end up with 0 equals 0. What does that tell us? That's true. 0 to 0 is fine. What? Infinite solutions. Why are there infinite solutions? Okay. There are infinite solutions. Okay. And basically what's happening in this case is if I have my first line, for example, going something like this, okay? And then if I graph the second line, it ends up that the second line is also going exactly like that. They're both the same line. That's why they're infinite solutions. Okay? So in this case, both lines are the same. Okay? And in terms of terminology, the book calls this dependent system. And so they're here, there are infinite solutions because basically every point on the line is a solution, right? And the lines are the same, right? So if later you're home and you're playing on Desmos, if you graph these, you'd find out that they're exactly the same line, right? And so you get infinite solutions here, right? 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 So there are three possibilities. We could get an answer. Okay. It could be that the lines are parallel and there is no solution. Or it could be the lines are exactly the same line and there would be infinite solutions. Okay. Are the possibilities. All right. Let's see how this can go. All right. All right. All right. Everybody take a few moments and solve this one. In this case, you do come out with two nice whole number answers. I know you're all disappointed that I gave you a problem with whole number answers. You were already just waiting to do another one with fractions. Okay. Okay. But so you get two nice whole number answers here. Right, so two nice whole number answers for this one, which means everybody should be happy. Got your numbers? Still thinking, all right, okay. Two numbers. You get two answers, one positive, one negative. Let's see. One will be a composite number. The other one will be a prime number. Provided you remember what composite and prime numbers are. Yeah. Well, you know what the answers are. You can check and see how everybody's doing. I say, you know what the answers are. You can check and see how everybody is doing on this one. You know it. You know the answers, right? Of course you. Yeah. I know you. You're just like watching her work, huh? Oh, okay. There should be whole numbers. So if you got a fraction going on, then there's something wrong. All right. So what are you getting rid of first? The y. Okay. Somehow the y's just automatically just disappeared. So you multiply by 30, 35, And 5 times 191.
Oh. Okay. Okay, I see.
Okay. Okay, all right, so that's okay then. And then 28, 35, 37 times that. Okay, all right. Add those together. 955 minus 259. All right, and then you divide it.
I've got a decimal, like I can.
Okay. Okay, so
But the steps are right.
there's something right. You just got to figure out. You just need to learn how to plug in the toy. Okay. All right. You should get 2 whole number answers. Yes. Right. One positive, one negative. One is a composite number. The other number is a prime number. Providing you remember what prime numbers and composite numbers are. Yeah. So yeah. 12 and yes. All right. See? Okay. Again, you should get 2 nice whole number answers for this one. Right? One will be positive, one will be negative. But they do come out to be 2 nice whole number answers, which means everybody should be happy. Right? 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 What are we doing here? Doing this? Got it solved? All right. Right. Got the numbers? Got the right numbers? You think so? And what we got? Those will be the numbers. Yep. Easy stuff. Wait until we get the 3 equations, 3 unknowns, then you'll really enjoy it. Even more fun. All right. Got it. Know it all right? Sorry. No. It's fine the way it is. You get nice whole number answers. But then if the top one says the way it is, you would not work out. You'd have to change the top one too. So, all right. So again, this one, you do get nice whole number answers for this. So again, you first decide whether we're going to get rid of the X's or the Y's first, okay? Again, for me, I would get rid of the Y's first because you already have a plus or a minus going on, right? And so you need a number 5 and 7 to go into, okay? 35, right? You don't have to try to figure out what that number is, okay? All right. And so I can multiply this by 5, multiply this by 7, okay? Okay, we know that'll work, all right? So we multiply everything by 5. And so this is going to be a 30x, a 35y, and then 191 times 5 was 955, right? And then we multiply the bottom one by 7. And so this is going to be a 28x, 35y, and then 7 times the negative 37. What was that? 259, right? Right. Add that all up. We end up at 58x. The y's go away. And this gives you 696, right? And then we divide. And we end up that x is 12. And once you know that x is 12, you go back to either one of the original two. And so if I take this one, this will be 4 times 12 plus 5y equals a minus. This will be 48. Take the 48 over. And so 5y equals a minus 85. And we get a negative 17. And 17 is a prime number. We know what prime numbers are, right? Yes? Right? Prime numbers? So what is a prime number? Can't divide where? In half? No, that would be a whole lot of numbers. Okay. So a prime number is a number that can only be divided by 1 and itself. Right? That's a prime number. All right. What is the smallest prime number? No. What's the smallest prime number? No, 1's not a prime number. No. Smallest prime number is 2. 2 is the smallest prime number. Yep. 2 is the only even prime number. Okay. Yeah. All right. But again, a prime number is a number that can only be divided by itself and 1. All right. So 2 divided by 2 is 1. Right. And then you can divide 1 into 2, and that's it. Okay. That makes it a prime. So 2 is the only even prime number. All right. All right. So what's a composite number? We did prime numbers. What's a composite number? As I said, one number was prime, which is a 17, and the other number was a composite, which is the 12. No? So basically, this number can be written as a product of prime numbers. Okay. That's, after all, this can be written as 2 times 2 times 3. Okay. All right. All right. All right. Well, let's see. We did that. We did X's and Y's and all that sort of good stuff. How about one like this? Mixture problem. So in this case, we have in terms of coming up with mixtures of various nuts for selling. And so we have in terms of macadamian, and then we have pecans. Okay. And so this guy comes up with a couple of mixtures. He's got 30 pounds of the macadamians. We have 70 pounds of the pecans, and the selling price is $939. And then the other mixture is 50 of the macadamians and 50 of the pecans. And this one sells for $899, right? I want to know what was the unit price for the macadamians and the pecans, right? So what is the unit price on the macadamians and the pecans? And this will be in terms of dollars per pound. So the first mixture was 30 pounds of macadamians plus 70 pounds of pecans for $939 for the entire lot. And then the other one was 50 of the macadamians and 50 of the pecans for $899. So I want to know, what is the unit price on the macadamians and the pecans? And it will be terms of a price, so dollars and cents. Okay. So in this case, we want decimal for this. We are, so we're going to solve this the same way we've been solving all the other problems. Okay. So that's no different. Okay. Right. How much? Nope. Nope. All right. So what is the price on the macadamians? What were the price on the pecans? And again, it'll be in terms of dollars and cents. And it comes out to be nice numbers in terms of that. Okay. All right. Right. Yeah. So, yeah. Okay. All right. All right. And you get nice numbers in terms of a price. Okay. It does come out to be nice terminating decimals in terms of dollars and cents. Okay. So, okay. Right. Again, should get nice numbers in terms of a price of something, okay, for this. And we got, yep, those would be the numbers. Right. Again, you get nice numbers in terms of a unit price on something. Okay. This time will be a decimal. In terms of dollars and cents for this. All right. Numbers. You got numbers? No numbers? Numbers. Still working on numbers? Okay. All right. All right. All right. Okay, so let's finish this one up for the day. All right. So again, should get nice numbers in terms of unit price on an object for this. So let's see, I'm going to get rid of the M's first. So I got a 30 and a 50. So if I take the top one, multiply everything by 5, take the bottom one, multiply by a -3. That way we can change all our signs here. Right? So this is going to be 150, 350. And then 5 times that ends up being 46.95. Multiply the bottom one by -3, we get a -150. Minus 150p. And this is a minus 26.97. And the M's go away, so we get 150. And this comes out to be, not 150, sorry, 200. Right? 200. And this is 1998. Okay. And then we divide. Yep. And we end up that the pecans come out to a unit price of $9.99, right? Right? So once you get that number, you can take that number and substitute it into either one of the original two. And when you do that, the macadamians come out to 799, okay? So you should get M is 799, okay? And again, you would take your number we got for P, plug it in, and then get the M value, right? Show mixture problem, right? Right. Any questions on all of that? Everybody's good? All right. So tomorrow we get to move on to bigger and better. 3 equations and 3 unknowns. All right. So we can keep on going. 4 equations, 4 unknowns. 20 equations, 20 unknowns. No, we don't go that far. She's panicking over there. No, we'll stop at 3. All right, with that, we will call it a day. And we'll see everybody again tomorrow. All right.